Hey guys, this is Coach Lowe, and today we're going to be talking about some geometry. And we are in Chapter 5, Section 4, and we are going to talk about indirect proofs. We've looked at direct proofs like two-column proofs, but today we're going to talk about indirect proofs, and these are kind of fun. I think you're really going to like these because you guys, most of you really like to argue. So this is kind of an argumentative section. If you'll just bear with me for just a second, you'll see what I'm talking about. So an indirect proof uses indirect reasoning. So what we are going to do in an indirect proof, it's also called proof by contradiction, is we are going to, just for a second, assume that what we're trying to prove is not true, that it's false. And then we're going to show that that completely cannot happen, and therefore it would be true. So here are some steps. All right, step 1. We are going to identify the conclusion. Remember, we did that with two-column proofs because that was our goal. And we are going to make the assumption that the conclusion is false by assuming the opposite is true. So make the assumption that the conclusion is false by assuming the opposite of the conclusion is true. All right, step 2, and we'll go through these in just a second, and I'll point these out to you. Step 2, then we will use logical reasoning to show that this assumption totally contradicts the hypothesis. So we'll kind of walk through either definitions, postulates, a theorem, or a corollary, and we'll show that there is no way that that could happen. All right. So we'll use logical reasoning, and we want to show that the assumption leads to a contradiction of the hypothesis. A contradiction of the hypothesis. And like I said, we can use definitions, postulates, theorems, or corollaries. All right, step 3, last step will be, we will identify or point out that since the assumption leads to a contradiction, that the original conclusion that we were asked to prove has to be true. So proof by contradiction. So since the assumption, so we went totally the opposite, right? We were assuming the opposite of the conclusion. So since the assumption is a contradiction, then the original conclusion is true. All right, so let me show you this, because this is going to be kind of fun. I think you'll like this. I don't know what that word is, but it's supposed to be true. All right, so let's first just practice on step 1. Step 1 is when they give you something, you say the opposite. You guys should love this, right? Because when I say things like, hey, this is going to be fun, you're like, no, it's not. See, that's the opposite. And then I prove you wrong by contradiction. All right, so EF is not a perpendicular bisector. Remember, that's a symbol for perpendicular. All right, so what's the opposite of this? EF is a perpendicular bisector. Good. All right, second one. This is still step 1. So if I tell you 3x equals 4y plus 1, what's the contradiction or the opposite of that? Yep, 3x is not equal to 4y plus 1. All right, then the last one. If B is the midpoint of LH, and LH is 26, then BH is congruent to LB. All right, contradiction. BH is not congruent to LG. I think I said LG, I meant LB. All right, so B is the midpoint of LH, so you can kind of draw that. B is in the middle. There's LH. These two would be congruent because that's the definition of midpoint. But we are supposed to do a contradiction of this. BH would be congruent to LB. That's true. But we want the opposite. So BH is not congruent to LB. All right. So let's try one. All right. So let's say that I give you the inequality negative 2x plus 11 is less than 7. Then x is greater than 2. All right, x is greater than 2. All right, so we want to prove this by an indirect proof. Don't solve the inequality. We do not want to do it that way. So now we're going to assume a contradiction here. We want to assume that x is not greater than 2, which means x would be less than 2 or x would be equal to 2. All right, so there's step 1. All right, step 2. We are going to prove this assumption is wrong. All right, so let's make a little table and let's pick values for x that go with our contradiction here. All right, so let's say, and then we'll kind of plug them in and see what we get. So let's say that x is 2, because in our contradiction we said x was equal to 2 or it can be less than 2. So how about 1, 0, negative 1, negative 2? We can go ahead and do negative 3. And let's plug these in and see if it's in fact less than 7. All right, so when I plug in 2, negative 2 times 2 plus 11. So negative 4 plus 11 is 7. Nope, it's not less than 7. It's equal to 7. All right, so let's plug in 1. Negative 2 times 1 is negative 2 plus 11 is 9. Nope, still not less than 7. When I plug in 0, my numbers are getting bigger now, aren't they? When I plug in negative 1, I get positive 2 plus 11, 13. This is getting worse. All right, and then 15, and then 17. All right, so in both cases, x is less than 2, which is from here down, or x equals 2, we have a contradiction. It is not, I don't get numbers that are less than 7. All right, so let's make a statement of that. In both cases, x is less than 2 or x equals 2, the assumption leads to a contradiction. Therefore, remember the 3 things for therefore, so we don't have to write it out. Therefore, x is greater than 2, our original, what we were originally trying to prove, our original conclusion, x is greater than 2 must be true. So the opposite, all of that was false, which means the original must be true. All right, cool. Let's do another one. Let's do something a little bit different. Let's say that Marta signed up for 3 classes at a community college for a little under $156. 3 classes, $156, a little bit under that. So less than $156. There was an admin fee, an administration fee, and in this $156, and it was 15. The class costs are all equal. So they're all the same cost. How could we show that each class costs less than $47? Each class was less than $47 a class. All right, so let's kind of break this down. What are we given? Well, we are given that she spent less than $156. We have an admin fee of 15. We are supposed to prove that at least one of the classes cost less than $47. We need to show that all of them are less than $47. So let's think about that. That means 3x plus 15, if all the classes are equal, 3x plus 15 is less than $156. So this is the total that she spent. This is admin fee. And this is 3 classes that she took. And this is the cost per class that we don't know. So hopefully that makes sense on the setup. All right, then we want, what we'd like to end up with is that X is less than $47. All right, so let's see if we can do this by contradiction. So step 1, X is greater than 47 or X is equal to 47. Now look at this, we could actually write this together. X is greater than or equal to $47. We can smash them together. We could have done it on the last one too. All right, so let's see step 2. We could make a table. But in this case, we know that we need 3 of those that are equal. So let's just pick a number that would satisfy this. So you can do 47, 48, 49, 50, it doesn't matter. I'm going to do 47 because it's the smallest number possible. So I have 3 classes that are $47 and $15 should be less than 156. Now listen, we could also just say 3 times 47 plus 15 is less than 156. You don't have to write all that out. Let's make this easy. We could just plug it in right there. All right, so 3 times 47, that's 141, plus 15 is supposed to be less than 156. Well, that's actually right at 156. This is not true. I don't know what that word is again. I'm having trouble writing the word true today. So that is not true, which means it contradicts. So this contradicts our first statement that the total cost was less than $156 because we got equal to $156. So my assumption here in step 1 that X is greater than or equal to 47 is false, which means our original conclusion is true. All right, so therefore one class must cost less than $47. All right, yay. Okay, let's try, let's do one more. Let's do a triangle this time. And I'll probably have something fun for you to do in class like this when you come back to see me. Of course I will. You probably won't even be able to sleep tonight because you're going to be so excited about that. I know, I shouldn't have said it. All right, I shouldn't have told you. All right, so JKL, this is 5, 8, 7. All right, triangle JKL with side lengths 5, 7, and 8 as shown. Prove the measure of angle K is less than the measure of angle L. All right, so step 1, assume the opposite. The measure of angle K would be opposite of less than is greater than or equal to the measure of angle L. Well, we know about side lengths, right? We know the angle side relationship, so this is step 2. Angle side relationship says smaller side with a smaller angle. So angle side relationship, let's see, JL, which is opposite of K. So let's put that first, JL. And then angle L, JK is opposite. Oh, 7 for JL, 8 for JK, which means JL is less than JK. Okay. Let's see. Oh, let's go on with the contradiction. I'm sorry, I did the true thing. So angle side relationship, that means JK should be greater than or equal to JL should be greater than or equal to JK. So I'm following this contradiction thing. If K is greater than or equal to L, then JL, which is opposite K, should be greater than or equal to JK, which is opposite L. Whoops, that is not true, is it? All right, so step 3, this is a contradiction. All right, contradiction of the given side lengths, because they gave us that JL is 7 and JK is 8, which means JL is actually less than JK. So therefore, since we have this contradiction, that contradicts our step one, our assumption, which means our original conclusion must be true. All right, so this is false, which means the original must be true. So therefore, the measure of angle K has to be less than the measure of angle L. And we are done. Remember, when we're finished, we can put QED for done. Actually, it means finished. Look it up. It's Latin. Look it up. All right, guys, I'm through. We had a little Latin lesson there, all kinds of fun stuff going on. So I'll see you guys soon. This is Coach Lowe, and I'm out.